Okay, let's try another one. This one, if you want to pause after I give it just to see, give it a shot. We're going to do the sum n goes from 1 to infinity, x to the n over n 3 to the n. Okay, so our a sub n is x to the n over n 3 to the n. Again, using the ratio test yet again, right? Guys are getting sick of it, I know, me too, but not really. Now let's do it over here. So limit as n goes to infinity, a sub n plus 1 over a sub n. Limit n goes to infinity, x to the n plus 1, n plus 1, 3 to the n plus 1, times n 3 to the n over x to the n. Okay, a lot of stuff cancels. N goes to infinity. So we're going to get, let's see, absolute value x n over n plus 1, and there's a 3 there. Okay, so that's going to equal absolute value of x over 3 as n goes to infinity. Okay, so this is going to converge if the absolute value of x is less than 3. It diverges if the absolute value of x is bigger than 3. Now let's take a look at what happens at plus or minus 3. If x equals positive 3, then what are we going to get? If x equals positive 3, we're going to get the sum n goes from 1 to infinity, 3 to the n over n, 3 to the n. Look at that. These just cancel. N goes from 1 to infinity, 1 over n. So this is a harmonic series, which we know already by now is divergent. Okay. What about if x equals negative 3? If x equals negative 3, then what are we going to get? We're going to get the sum n goes from 1 to infinity, negative 3 to the n, 3 to the n. That's just going to be the alternating harmonic series. And that is conditionally convergent. Okay, so our power series converges, yes at negative 3, no at 3, yes everywhere in between. Okay, all right, one thing I want you to notice, this one converged at the right endpoint. This one converged at the left endpoint. Okay, so there's all sorts of things and nice little plays we can make. Okay, in fact, let's do one that sort of puts that all together in my next video.